Hello everyone, let's look at this limit problem here. We are going to use L'Hopital's rule again, but as you can see, this is a product, this is not a quotient, so we cannot just apply L'Hopital's rule directly to evaluate this limit. But in general, when we start a limit problem, we usually just plug in the number and see what actually the function will be approaching to, or what kind of form that the function has. Okay, so let's begin. So I'm going to start by just looking at the form of the function, which has the form of square root of some quantity, and that quantity is the x, and then times the ln. Okay, so the ln of also some quantity. And what is that quantity? It's x is approaching 0 from the right side. And so we are going to put that in here, then also put it in here. And then now we try to analyze the form of this one. And this square root of a quantity that's approaching 0 from the right side, and so as you can see that's also approaching 0 from the right side. Okay, so this quantity right here, it's also approaching 0 from the right side. But what about this ln of some quantity? That quantity is approaching 0 from the right side. This one is actually approaching negative infinity. And it's really because if you look at the graph, for this function here, and actually you are going to get something that looks like, so I'm just going to draw a tiny graph right here just to show the idea. Well, actually, I think I need to just draw it higher. Okay, so this horizontal axis is this higher. And so what is the graph for this ln function? It actually is, it looks like this. So do you see what's going on here? When x is approaching 0 from the right side, then what happens to the y values for this function? It's actually going down to negative infinity. So we are actually getting a product here of 0 and negative infinity. And so that's another indeterminate form. This is called the indeterminate product. And so we actually have no idea what this thing is approaching to. And so we first need to manipulate this function. So how do we do that? It's this. First, we are going to decide that which function that we can move to the bottom of the whole quantity. And then that sounds a little bit confusing here. What does that mean? What that means is that at the beginning, you can actually treat. Okay, so at the beginning, you can actually write this function as a fraction. How do you write it? You can just put 1 under it. So this whole function is actually dividing by 1. Okay, so we just put a 1 at the bottom, so now it looks like a fraction. What do you do in the next step? We can think about putting the square root of x at the bottom by doing some algebra manipulation, or we can also do it to the ln of x. It depends on which one is actually easier for us to differentiate once we move it to the bottom. So it turns out that because the square root of x can be written as x to the 1/2 power, and so manipulating just the power when we move into the bottom will be easier for us than moving this ln of x to the bottom, which will give us 1 over ln of x. But that's not good, right? So if you're more visual, right, I can actually show you the two cases right here. Then you can see why we're going to move the square root of x to the bottom instead of moving the 1 over ln of x to the bottom. So let me show that here. It's this. So two cases. One of the cases is that if we move the square root of x to the bottom, we are going to get ln, okay, of x over, and then because that's initially x to the 1/2, so if you are moving it to the bottom, then you are going to use the rules of exponents to do this, which will give you x to the negative 1 over 2. Okay, now, and then compared to the other case where we are moving the ln of x to the bottom, which will give us the square root of x over 1 over ln of x. And so imagine that you are going to apply L'Hopital's rule on the fraction. Which one do you think is easier? And of course, we really just want this one, which looks better. Is that good? Yeah, so we are going to use that one. Now, we actually don't need this anymore because we may need more space for our calculation, so let's move it away. So we are going to use the first case. Okay, so let's move it to the bottom. We are going to get, let's just put down the limit right here, and we are going to get ln of x at the top. And as I just showed you already, we would have x to the negative 1 over 2 at the bottom. Yeah, so initially, as you can see, this is x to the 1 over 2. So once you move it to the bottom, it becomes what? X to the negative 1 over 2. So now let's check the form one more time. Just like before, we are going to get negative infinity for the ln of x, right? But once you put the 0 in here, it becomes a fraction, as you can see here. So if you put 1 over this 0, then you are going to get infinity. Now, I can show that right here, which will turn out to be, let me see how to make it so that it will be easiest. Okay, I can actually do it here. So this one looks like what? This one looks like 1 over square root of x. So imagine that you are going to put the 0 in here. What does that give you? That you are going to get a small number at the bottom, and when you take the 1 divided by that small number, you're going to get a big number. So this quantity is actually approaching infinity as x approaching 0 from the right side. And so see what's going on here? You have the form of infinity over infinity. And actually the top one is negative infinity, but the sign does not really matter here. We can apply L'Hopital's rule in the next step. Okay, so we are going to now apply L'Hopital's rule in the next step. And yeah, so just like usual, I'm just going to put an indication here that I'm using L'Hopital's rule. Then what are we going to get here? We are going to take the derivative of the ln of x, and that will give us 1 over x. What about the bottom? The bottom, we are going to use the power rule to do it, which will give us negative 1 over 2, and then x to the negative 3 over 2. Okay, yeah, so we are not using the quotient rule here. Just make sure that you are not using the quotient rule. We are just taking the derivative of the top and the bottom separately. Okay, now when you see this, don't just try to apply L'Hopital's rule over and over. We actually should simplify this and see what the function looks like. Okay, so let's do that. Yeah, so in this next step, we are going to be simplifying the function. And so first, how do we do it? We can put the 1 over x on the side. Then we are going to get 1 over x, right, like this. And then what about this negative 1 over 2? This negative 1 over 2, it's in the denominator. You can actually move it to the numerator, and then you are taking its reciprocal, which will turn out to be negative 2. Okay, so now it becomes negative 2 here. And this thing is also the same situation here. You have a negative exponent in this factor. And what happened is that if you move it to the top of the fraction, then you are going to remove this negative sign due to taking the reciprocal of this quantity. And so we are just going to get x to the positive 3 over 2. So that's the thing that I'm changing. Okay, now as you can see here, the only thing that's in the denominator right now is just this x. The negative 2 is in the numerator, the x to the 3 over 2 is in the numerator, so we can actually simplify. We can reduce this fraction right here by dividing top and the bottom by x. Then if we are to do that, then what are we going to get here? I'm going to divide the bottom by x, I'm going to get a 1 here. If I divide this by x, then I'm going to take away the 1 from it, as you can see. And then, of course, we can do some calculation right here for this thing. This thing is 3 over 2 minus 2 over 2, so that will give us, what is that? That's just 1 over 2. Okay, so we are going to get x to the 1 over 2 here for this thing here. We didn't do anything to the negative 2 because we don't need to worry about it, right? Okay, so now next step, we are going to we clean up the expression so that it becomes, what is that? We get negative 2. And then what do we have there? That's x to the 1 half, right? That's x to the 1 half. Okay, do we still have an indeterminate form? Actually, we don't, right? As you can see here, you can just directly plug in the 0 and then we will get the answer. And if you directly plug in the 0, then you are going to get negative 2 and then times something raised to that 1 half power. What is that? Something that we are plugging in? That's just the 0 here, right? If you plug that in, you have the final answer, which is what is that? That's just 0. So that's our final answer. Okay, so as x is approaching 0 from the right side, this function is approaching 0. Okay, so that's it for this problem. I'm going to do a more complicated problem next time. And yeah, if you like my video, please subscribe to my channel and give me some support. Thank you. See you next time.